Good morning, everybody. We are going to move on to the section 5.3 notes. This is on proving triangle congruence by SAS. And SAS, it stands for side, angle, side. So we have the side, angle, side congruence theorem. And that theorem says if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the two triangles are congruent. All right. So they give us a little example down here. They said if segment AB is congruent to segment DE, so AB is congruent to DE, angle A is congruent to angle D, and segment AC, this guy, is congruent to segment DF, then we can come to the conclusion that our two triangles are congruent. Now, we're going to run into other examples as we go through this unit. There's going to be other situations where you don't always have these two congruent sides and their included angle. Sometimes you might know information about all three sides. Maybe you know just information about the three angles. Maybe you know two angles in one side. All of those have different levels of proof associated with them. So some of them let us decide whether triangles are congruent or not. But the side, angle, side congruence theorem, it's one of those that if we can find that information or find enough evidence between the two triangles to show we've got a side, an angle, and a side congruent to each other in each triangle, then we can officially say that those two triangles are exactly the same size. So let's take a look at a couple examples down here. These are pretty good examples. They're a little less obvious what's going on, but we'll read through them. So it says, decide if there's enough information within the diagram to prove the triangles are congruent by side, angle, side. Now, let's look at this first one and kind of take inventory. What do we know? We know that this side is congruent to that one. We know that this angle is congruent to this one. And we know that these two smaller angles are congruent to each other. What else do we know about them? Kind of looking at them, they seem to share this one side right down the middle. So because they share that one side, I know that this triangle and that triangle have a side in common. So if I drew those two triangles separately, you don't need to do this really, but if I drew those two triangles separately, right, oh, that was a bad one. Hang on, let me fix it. So kind of the goal here is to show those two congruent sides and their included angle are congruent. We need to check to see if we've got that. So we've got, again, those two sides, right? And I don't know if this makes a lot of sense, but I'm taking those triangles and sort of ripping them apart. Like if we separated them, I would still know that those two sides are congruent to each other. I would still know that those angles are congruent to each other and these angles. But since they shared that side when they were put together, I know that they also have that side in common. Now, we have a lot of stuff going on here. We've got two sides, we've got two angles, but we don't have two sides and an included angle. But we actually kind of do. So if you recall in our notes from the other day, we talked about something called the third angle theorem. All right, I'm going to write that down. The third angle theorem. And the third angle theorem says if we have two triangles and we know that two of their angles are congruent to each other, two sets of their angles are congruent to each other, then we also know that their third angles have to be congruent. And that's exactly what we've got going on here. Oh my goodness, there's so many marks. But writing it like this, showing it like this, we can see that we're given this common side, right? We were given that this side and that side are congruent. We showed that we have this common side right there, so I'm also going to jot that down. We had a common side. And we have those included angles congruent to one another. So, is there enough information to determine if those two triangles are congruent? Yes. How do we know? Because of the third angle theorem, and they shared that common side. All right, oh, that was a messy one, but let's keep going. Looking over here, we've got a lot of information. Let's see. We know that this side is congruent to that side. What else do we know? Looks like they share this little middle portion, right? And they also have these little segments congruent to one another. There's little like double tick mark portions. So if they have those double tick mark portions in common and they share that side or that part of a side in the middle there, then we know that this side of this triangle and the same side of the other triangle, so I'm going to use a different color, that side of that triangle, so we've got the green and the blue, those are going to be congruent to each other. And we have this other congruent side out here, right? So we have one side in common, we have that other kind of middle side in common, and just notice we've got a third angle theorem thing going on again. We know that they have those two angles in common, and they both have a 90-degree angle. So if they have two sets of angles in common, we know automatically, without even having to have numbers, we know that that third angle is congruent. So once again, we have the third angle theorem. And our triangles share a partial common side. So, do I have enough information to say that these are congruent by side, angle, side? I do. I'm going to try to darken this in just a little bit so you can really see it. We've got that side, right? We've got a side. We had this other side, that kind of middle side, and the included angle. Remember we talked about the included angles. It's the angle that is sandwiched right between two sides, right? So we've got a side, an angle, and a side. So we'll call that, or we'll say yes, those are congruent by side, angle, side. All right, moving on. Down here we have a proof. All right, there's not quite enough lines for this proof, so we'll have to add a few. But let's see what they gave us. So they said, given angle ABD and angle CBD are right angles, and segment BD bisects segment AC. So there's a lot going on here. Let's just focus on that first part. I'm going to try to cram all this in the box here. So we've got angle ABD and angle CBD are, I'll just say they're right. They're right angles. And we also know that segment BD bisects segment AC. All of that was given to us. Okay, so let's break some stuff apart here. What do we want to dive in first? Let's maybe talk about bisecting. So they're telling us that segment BD, right, this guy in the middle, is bisecting segment AC. Right, so that means segment AC is getting chopped right in half. And they actually gave us these little congruence marks to show it. So we can come to the conclusion that segment AB, okay, this first little part, is congruent to segment BC. How do we know that? Use the vocabulary that they gave you. They said we have a bisector in here. So we can say definition of, and this is a segment bisector. It is a segment that's getting cut in half. So we'll say definition of a segment bisector. That lets us say that we've got this one side in common, right? Now, again, we are trying to prove that these two triangles are congruent. So we're trying to lead into like a side angle side situation. We've shown that they have this one side in common, but now I need to find one more side and the included angle to be congruent to use that side angle side theorem. Now they told us that angle ABD and angle CBD are right angles. If they're both right angles, then we can say that angle ABD is congruent to angle CBD. And this is something we haven't talked much about, but it came up in our notes last unit, I think. It's the right angle congruence theorem. And this one sounds silly, but it just means that all right angles are congruent to each other. Okay? If you have a right angle, it's congruent to every other right angle that exists. So what did we just find? We just found that we have a set of congruent angles. So I'm going to throw a little A in there. We've got a side, we've got an angle. Now we just need to see if we have one more side that includes our angle. And we do. So we've got this side BD. Right? Both triangles share it. So we know it's going to be congruent between them. How we write that, though, gets a little goofy. We have to show in our writing, we have to show that that side is common to those two triangles. So we're going to say segment BD is congruent to segment BD. Okay, so this BD might be talking about the triangle on the left. That BD is talking about the triangle on the right. Okay, but they both have side BD. So we're showing that they share that side, that they have another congruent side. And this is actually, notice, it's something is congruent to itself. So that is actually the reflexive property of congruence. Okay, I honestly don't know that we've had to use that one up to this point, but the reflexive property does actually have a purpose. So we have shown that AB is congruent to BC. So we've got one congruent side. We've shown that angle ABD is congruent to angle CBD. So we have an angle. And we just showed that BD is congruent to BD. So we have another side. So we have a side, and the included angle. So that is enough information to say that triangle ABD is congruent to triangle CBD by side, angle, side. Okay, so we need to show in these proofs, we need to show all of those little steps, all those little pieces to really prove that they're congruent. All right, let's flip to the next page. All right, we have another proof here. It says the wings of a paper airplane have two congruent sides and two congruent angles. Use the side angle side congruence theorem to prove that triangle IPA is congruent to triangle IPR. All right, so let's figure out what given information we have here. They're telling me that those two sides are congruent to each other. So we could say segment AI is congruent to segment IR. And they also tell us these angles are congruent. So we could say, see, I don't want to just say angle I here because you wouldn't know what I'm talking about. But here's where I need three letters. I might say angle AIP is congruent to angle, so AIP is this one, is congruent to angle RIP, which is the one on the right. So that is all given to us. So I'm seeing we've got a side, we've got an angle, and once again, they share that sort of middle segment. So we can make note of that. We could say IP, segment IP is congruent to segment IP. How do we know that? That is the reflexive property of congruence. And now we have shown that we've got these two sides, AI and IP, and their included angle, angle AIP. And that is mirrored in the other triangle. So we've got a side, we've got another side, and we have their included angle. So we can say that triangle IPA is congruent to triangle IPR by side, angle, side. Boom, that's a short one. Right, one final proof to go. We are given a bunch of stuff here. So I'm gonna sort of split it out. So I'm gonna say segment AB is parallel to segment DE. Remember those lines. It's been a minute since we've used those lines, but that was given to us. Right, what else do we have? We've got segment AB is congruent to segment ED. That was also given to us. I'm gonna come over to my diagram just to check these things. AB is congruent to ED. AB and ED, they have also got those parallel marks there. What else? We've got segment CA is congruent to segment CE. Also given to us, and they've got that mark. CA is congruent to CD. Okie dokie. Now, we've got two sides. We have two sides already. We have a side. We have a side. So it'd be really, really cool if I could show that angle E is congruent to angle A somehow. And we can do that. Just notice we've got these parallel lines here. And you may need to sort of pretend to sketch these in, but if we have two parallel lines and they are being crossed by this transversal, remember some of this? We actually have a set of alternate interior angles sitting right there. So when you see parallel lines, that's a really, really good hint that we can use some of those rules, those alternate interior angles or alternate exterior angles or whatever the case may be. But we have just shown we've got two congruent sides between the triangles. We have their included angle. So, oh, what do we want to say? Sorry, I'm getting ahead of myself. We've got angle A is congruent to angle E. That is the alternate interior angles theorem. And lastly, we have enough information to prove our two triangles are congruent. So triangle ABC is congruent to triangle EDC. How do we know that? We've shown that there's a side, and the included angle congruent. So that's going to be a side, angle, side solution. All right. Look back through this video, follow along through it, but go back and check to see, like, why did we do things at each point? Make sure your final answer, if you're using side, angle, side, make sure your final answer is supported by all of your work. See here, we called out a side. Here we called out another side, and this angle was the included angle. So even though we did it kind of out of order, in the diagram, we actually have those two sides and their included angle. So that is enough information to say that our triangles are congruent by side, angle, side. All right. Have a great day. We'll see you tomorrow.